The longest side is opposite the biggest angle, which we already know, right? From doing our special triangles, 30, 60, 90, yeah? But even before that, you knew it from doing Pythagoras, right? 90 is the biggest angle. What's across from it? The hypotenuse, the biggest side. That's really common sense, isn't it? So the longest side is opposite the biggest angle, which means everything else is also true. Where's the shortest side? Across from the smallest angle. And the middle side is across from the middle angle, right? That's the first point that's really important. I hope she stressed it. If she didn't, I'm stressing it now. Okay? The second thing that might mess you up. Your answers must make sense. Because we are doing the sine law, your calculator might give you, I won't use 60, that messes us up, 65. Which makes, what's this? This is also 65. So if this theta is 65, if that's theta and it's 65, what is that theta? 180 minus 65, right? Now, if I did this triangle, 18, 67, 43, which is 110, which would make this 70, right? Yeah. And you did sine, and you got an answer of, no, that wouldn't work. This would be the tiniest one, 7. This would be 12, and this was x. If you did the work on this triangle, and I told you, let's make this 14. This triangle, what do you know about theta right there compared to 67 and 43? It has to be bigger than 67 and 43, right? So if you did all the trig and you got this to be 65, you would know that it's wrong. Your calculator would say 65 because your calculator found this one. But you know that this has to be bigger, so you know this would have to be the other theta. Is everybody cool with that? Yeah? Okay, then we're set to move on. Does anybody want to ask any questions about 167 and 68 and 69, apparently, and 70? Anybody want to ask about any of these? Obviously, you don't have the right answers, but it's easy to check, right? Anybody want to ask about any of them? I mean, really, it's just grade 10 trig, right? Except now you can do it with every triangle. Now, I hope also, I don't know if she did, but I hope Miss Clausen talked about A, B, C, a triangle like this, yeah? And she showed you, I hope, that the sine law comes from doing this. She didn't? Okay, well, it does. All right? In grade 10, if I had given you this triangle and told you to tell me theta, and you knew this side was 8 and this side was 12, it would be really hard to do, yes? Because there's no 90 degrees. But if I put this line here, I make a 90 degree, don't I? And now I could do trig to work this triangle out. Right? Math guys used algebra to build this from SOHCAHTOA. So you can trust that this works. Because all it is SOHCAHTOA, done twice. Is everybody cool with that? We can just go on? Okay. Now, I know if you were in my grade 10 class, you got questions like this. And I said, how do you find the missing side when there is no 90? And most everybody recognizes you got to cut it in half and make a 90. Once you cut it in half and make 90s, this is only one step away from that. Everybody cool? Okay. Let us move on then, cabbages, to page 171. And you see the word ambiguous triangles. Now, ambiguous triangles are what I was just talking about. A great many of you in this room might not know what the word ambiguous means. Does everybody know what the word ambiguous means? You're not familiar with the concept of ambiguity? Okay. Ambiguous and ambiguity are when you aren't sure about something. All right? You know how sometimes I'll look right at you and I'll seem really mad, and then 2 seconds later I go, just kidding. That's ambiguity. Huh? Yeah. Well, it's not quite having a double meaning. It's having an uncertain meaning. Okay? Everybody cool? And what can happen is what I was just talking about. You can have a triangle, right? And you do all the work with it, and your calculator says that theta is 65 when it has to be 135. Everybody with me? That's an ambiguous triangle. So it happens all the time, and it only happens with sine. So you got to be careful with it. So that's what we're going to talk about right now. Everybody cool? All right. So I want you to draw me a triangle ABC, with the following specifics. So this is what we know. So we need an angle of 30 degrees. Everybody cool? So let's just draw that. Doesn't matter what it looks like, does it? We're just going to draw an angle. 30. And I've said that is angle A. Everybody good? Yeah? Okay. Now, I've said there's a corner B and a corner C, right? Where do you think, or do you think it matters where I put B and C? Do you think that matters? Well, let's try. If I put B there and I put C there, this is BC. Does everyone agree? Okay, how long is BC? 3. How long is AB? 6. Is everybody cool with this? Okay, now, here's what I mean by an ambiguous triangle. If we didn't know the sine law and I wanted to work with this triangle, I would have to put this line in, wouldn't I? To make it 90 degrees, yes? Okay. I'm going to call this line Q. Some textbooks call that line H for the height of the triangle, but I find that confusing because we already use H for hypotenuse, don't we? So I'm going to call that line Q. Is everybody okay with that? Now, once I make that line, that gives me this triangle. Is everybody okay with that? All right. Now, in that triangle, what would I do with SOHCAHTOA trig, so only 90 degree trig, to find Q? How could I find the value of Q? You would do sine 30 equals Q over 6. Does everyone agree? And what would Q be? 6 sine 30, right? Now, we already know what sine 30 is from a 30, 60, 90 triangle, don't we? Can anyone remember? It's a half, yes? So that would equal Q. So that would be 6 times 1/2. And how did we know that was 1/2? 30, 60, 90 triangle, right? 2, 1, root 3. Oh, other way around. Sorry. Idiot. Sorry. 1, 2, root 3. No, I still did it wrong. Dummy head. Let's draw this properly. 60, 30. This is 2 opposite. No, it's not 1/2. It is 1/2. But why am I drawing that wrong? What the hell? This should be the 1. Oh, because it's sine 30. Idiot. Root 3. There we go. Sine 30 is 1/2. Yeah, everyone's cool? Okay, so what is 6 times 1/2? 3. 3 equals Q. Now, look at what happens here. I've told you that this side has to be 3, correct? Everybody with me? Now, really, what we drew was this. We only knew this 30 part, didn't we? It's the only thing we knew, right? So this Q line here has to be 3, according to this, correct? And what else do we know? The line opposite of A had to be 3. So my green line had to be 3. Is everybody with me? Which made a 30, 60, 90 triangle. Everybody cool? It had to be this, so this is what we find out, or this is what we know. If sine of theta, the theta we have, right? If it equals Q, then we've made one right angle triangle. There's no options, because this had to be 3, and we knew it was 3. It'll make more sense in a second, but is everybody cool with how I built the green triangle and how I built the pink triangle? Yeah? All right. Let's look at the next one, and you'll start to see what I'm talking about right here. I still have ABC, and I still have 30, don't I? And I still have, there's A. AB is 6, and BC is 2. So let's put B up here. This is 6. Still the same. Everybody good? If I drop this line down and make Q, we know that Q has to equal 3, doesn't it? Everyone agree? But what is Q? Because that would make this C, right? How long is BC? 2. How long does BC have to be to make a triangle? It has to be 3. Is it 3? So BC, which I'm going to draw a green line because that triangle's green, is only 2 centimeters long, isn't it? Will it ever reach here and have this still be 30? No. Right? So if your if your Q is less than your C, your other side, you can't make a triangle. This Q will just swing like a pendulum. Everybody cool? So if Q is less than C, there is no triangles possible. So if Q equals C, how many triangles are there? The one we just did. One right angle triangle. If Q is less than C, get rid of that equals, there's no triangles possible because the Q will just swing. Everybody cool? All right. Turn over the page. Do we have the same stuff? Okay. So we're going to draw with green. 30 and 6. And we know that Q is 3, yes? Right? Okay. Now, what's our third side of this triangle? 8. Is 8 bigger than 3? So we know it's going to make a triangle, yes? Everyone's cool? Okay, so if this is 3, I got another one. I got this green line. Could I go this way and have 8? I could. Could I go this way and have 8? No, why not? Because there's already a side there and it's 6. If I go here, I'm going to go past 6, aren't I? So I can't make that triangle, can I? So what do we know now? If C is greater than Q, it's got to go out to this side, doesn't it? How many triangles does that make? Can only be this one, right? Because the Q can only be that, right? So that means we can have one obtuse. What does obtuse mean? Greater than 90. One obtuse triangle. One triangle with a greater than 90-degree angle. Those are the 3 easy ones. Is everybody okay with them? You check the Q. Now, does it have... I'm only using 30 because we automatically know that sine of 30 is 1/2, right? I could change this to any number, and we would just find Q. Everybody understands that, right? I'm doing this so we can do the trig in our heads, so the concept of this is what we can think about. Is everybody good? So everybody understands how we would make one right angle triangle, no triangles at all, or one big triangle. Yeah? All right. Now we got to get to the one that causes actual trouble. So we start with this. 6, 30, and we know that Q equals 3. Everybody good? Now, what do we know about the fourth side? Third side. It's triangle, idiot. The third side is 4, yes? Is that greater than 3? So we know that if it's greater than 3, we could go this way, don't we? Because that would make this cool, right? But I could also go this way. Because that 4 is less than 6, yes? If it was greater than 6, it would stick out past and we wouldn't make a triangle. So this is the complicated one. This is the one that messes everybody up. If C is 6 is less... No, other way around. This is hard to write this way. If C is greater than Q and C is less than your known side, you have 2 possible triangles. Does everybody understand? I could have the green one, or I could have this peachy one. Is everybody with me? Because my third side is between Q and my known side. This is what I mean by ambiguous. You don't know which triangle I have here. Now, where does this come into play? If you actually have to use a map for something, like pilots or plotting a course with a boat, or doing search and rescue or something like that, if you actually have to use a map and angles, then you got to be able to be aware that you might have 2 options. Because if you're trying to find some stranded hiker who's at this point, he could be there or there. Everybody understand? Yeah? All right, let's try a couple of these. So 173 we should be on right now. Notice I'm not using 30 anymore. So what does that mean we have to do? We actually have to do some math, right? We can't just do it in our head. But does the method change? No. So we start with an angle we know. How big is this angle right here? 58, right? If that's angle A, then little a is over here, right? Somewhere over here. Little a would be red, somewhere over here. We know B is 10, right? Well, the only side of this we have that we can work with is to make that 10, yeah? So that's little b. So that puts big B somewhere out here, agreed? All right, let's make the triangle. What do we need to do before we can make a triangle? We need to know our possible options, yes? And what finds us those possible options? Q. What do we know about Q? We know that Q equals what? Go back to the notes we did. Bring your prior knowledge with you. Q equaled the side we had times sine of our angle. So what is Q here? The side we have, which is what? 10, times the sine of the angle which we have, which is 58. So what does Q equal? Pardon? 8.5. And we're happy with one decimal place. Now, is 8.5 for Q greater than or less than the side we know? Less than, yeah? Okay. So that means if it's less than that, it could reach all the way down, yes? Can it go this way? Could it go this way? Think about it. Talk to your neighbor for a sec. Can it swing both ways? Can it swing like a pendulum? Or am I locked into a certain triangle here? Think of my options. The third side of my triangle has to be how long? Read in the question. How long is the third side of my triangle? 20. Right? I have 8.5 to play with here. That third side is bigger than 8.5, yes? So, is this allowed? Could I go down there with 20? No, why not? Doesn't make a triangle, it makes a 4, yeah? Okay. So it can't be a right angle triangle. Can it go this way? Why not? It doesn't make a triangle. It's longer than 10. So what's my only option? Has to go out here. Right? So here's B, here's 20. Now, can I solve this triangle? Do I need Q anymore? Q made me draw the triangle, so now I'm good without it, yes? Now can I solve this triangle? Do I have a pair? I do, don't I? So which do you guys prefer, sine in the numerator or sine in the bottom? Okay, so you guys, we have 20 over sine 58, yeah? Everyone agrees? Okay. So what then is this guy? That's, well, B, right? But we know this, don't we? So isn't this 10 over sine B? Can we solve that? How? What's the answer? Don't give me the answer. What's the work that we would do? 10 sine 58 divided by what? 20. And since I need an angle, I would have to shift sine that, right? Okay, that gets me this guy. What is he? What? 26. Now, do I know this now? Why are you looking confused, Damaris?
Oh, just because I got 25.08, so
Oh.
it's just 1 degree.
Yeah, but no, it matters because when I do 26, if I do the work and you don't have that, then you make a confused face. You don't really know what's going on. So let's check. 10 sine 58 divided by 20, shift sine. I get 25.08 as well. So 25 degrees. I am betting whoever told me 26 just saw the 8. So if that's 25, what is this automatically? How do I find that angle? 180 minus 58 minus 25, correct? And that makes that 97. Now, can I do this? What's this side? If that's A and that's B, what's this? C, so what's this? Little c. So, little c over sine 97 equals, I'm just going to use 20 and sine 58, right? Because they're exact. 20 over sine 58. How do I find little c? 20 sine 97 over sine 58. And I get 23.4. Now let's check. Is the biggest angle across from the biggest side? Yes or no? Is the littlest angle across from the littlest side? Yes. So have we solved our triangle? And now we know exactly where the missing hiker might be. Everybody cool? Okay. Is B any different? Should I do B any differently? Do I have an angle? So I draw it. And that angle is what? 71, right? A is across from that. So somewhere out here is 12. What does that make this then? What do we have to make it? 17. Excellent. Does that allow me to find Q? What is Q? 17 sine 71, correct? Which is what? 16.1. Everybody cool? Now, this side is 12. Is that less than 16.1? Will it ever reach? No. Because Q down to here is 16.1. I only got 12 to work with. It's never going to reach, is it? So how many triangles is this? None. It can't happen. Everybody cool? Okay. Do you understand that that line has to be 16.1? Right? Okay. Stand up. You are 16.1 tall. Okay? Catch. That is 12. Hold it by your head. No. Pointing to the ground. Right there. Does it reach the ground? Turn it either way. Swing it. By your head. Swing it. Does it ever touch the ground? That side is 12. It doesn't reach the ground. Just like that meter stick is shorter than your height, so it will never reach the ground if it's attached to your head. With me? Nice! Does everybody understand why it doesn't reach? It's just going to swing like a pendulum. Why do I keep saying swing like a pendulum? How do you think those guys 300 years ago, 500 years ago made clocks with pendulums? Everybody good? Okay. What's weird about the next one, and why are all of you going to say, oh my God, I can't do it? Because it's not A, B, and C. Does it matter? No. If I came in here one day and told you my new name is Rainbow Triumph, after you were done laughing at me, would you learn math? Yes, you would. You would say, Mr. Myers, I would say, oh, Mr. Rainbow Triumph. Understand? It wouldn't matter, would it? Okay? So, yes, of course. How are we going to start this question? By doing what? What is the first thing we're going to do? We're going to draw our angle. And what value does that angle have, Lucas? 35. Nicely done. Which makes that D. So what does that make this? This has to be the 230, correct? And somewhere out over here has to be a 133, right? But I don't know if it's going to be out here or here or here, right? How do I find that out? That's why I got to do Q. Q equals what? 230 times sine 35, right? Which is what? 132, yeah? Well, I got 133 to play with. So that is 132. Is that 133 bigger than 132? So can it go straight down? No, because that would make a 4. It has to go... Oh, I didn't want to use pink. It has to go there or there. Why is this a 2 choice? Because that is less than that. So it can swing this way or this way. Everybody cool? So I either have this triangle slightly to the left of Q, or I have this triangle slightly to the right of Q. But in both triangles, this is 35, this is 230, and this is 133. Is everybody cool? And then we would just do sine law. Everybody good? Do the letters matter? No. Now, did I give an assignment for this? Did I give any work? I didn't. Okay. Everyone's good with this? All right, now listen, I want to show you guys something that is going to might cause some of you concern. In your books right now, is the very next page notes? Son of a motherless goat. Keep flipping. You should get some blank pages soon. Everybody's got a blank page on what page? Please turn to 190. Because this is something I always forget every year, that I need to do a special page for this, and I always forget to put it in. Because it's something I do a lot of in grade 10, and I forget that you guys sometimes forget stuff. If all of you would be so kind on that page 190 to draw me one of those, that would be very helpful. So far this year, this has been the Cartesian plane, yes? X's and Y's, yeah? What other application does this drawing have for us as people? Where else do you see something that looks like this? I'll put some arrows on it, see if that helps. A compass. What is this? North. What is this? East. What is this? South. What is this? West. If I tell you I'm going for a walk, I start right here, don't I? If I tell you I am walking northeast, what direction am I walking? I'm walking this way, yes? If I'm exactly northeast, what is this distance in degrees? 45. What is this distance? 45. Could I then do trig? Does everybody understand? Okay. So everybody understands the basics of that, yeah? Now some of you this will be reminder, some of you this will be new. There's two ways we talk about direction. The first way is on a 0 to 360 degree scale. North is 0 degrees. Now, on the Cartesian plane, we started here and went counterclockwise, didn't we? For directions, we go clockwise. So if I tell you I am walking at a heading of 63 degrees, I start right here on my red dot. Where am I walking? Into what quadrant will I be passing? Quadrant 1. So I will be walking this way. And where is the 63? Is it A or B? It is in A. Does everybody understand that? And if that's 63, what's this? 27. Is everybody cool? All right, I'm going to ask you to do one of your own. That should have been red to do 63. Okay, I'm going to give you another one. I'm walking at a heading of 197 degrees. Where am I walking? Into the third quadrant. Yes? Down here. Everyone agree? Can I do trig with that yet? No. If I knew this, could I do some trig? What is this? 17. If I knew this, could I do some trig? What is this? 63? 73. Is everybody cool there? Okay. Here is Myers. Here is Jazzcarn. How far apart are we? I haven't given you any distances. How far apart are we? If I tell you I walked 18K and Jazzcarn walked, because he's younger than me, he walked 21K. Could you tell me how far apart we are? How? What the hell? Oh well, guess we're taking this up tomorrow. Have good days.